Hello colleagues, my name is Antons Sincovs and I'm a technical support engineer at Zabbix, and today I will present you a brief outline of topics related to problem event generation at Zabbix. So let us start with the overall workflow for problem detection. So in order to detect a problem, you first need to obtain the data that you will be evaluating. And in order to do this, you need to create an item. And here is the fields, the parameters that you need to define when creating an item. So you need to assign an item unique name, then you need to specify the type of the item. In this case, it is a Zabbix agent. Zabbix agent, let me remind you, this is an optional Zabbix component which is installable on virtually any operating system and collects data on the operating system level. Then you need to specify the key. In regards to Zabbix agent, this is one of the known metrics that can be collected by the Zabbix agent itself. So this is system CPU utilization. So type of information is numeric with floating decimal point, and the host interface that is used to connect to the Zabbix host with the Zabbix agent is this. Also, you need to set up an update interval. This is how often the metric value will be updated. Once this item is created and you receive as data, you can then evaluate this data in a trigger expression. The example expression uses a minimum function which evaluates system CPU utilization, the item which is referenced by the item key, for the last 5 minutes if this minimum value exceeded 80. The value is received in percents. So if the minimum value within the last 5 minutes has been greater than 80%. And what happens then? If this trigger expression is evaluated as true, a problem event is generated. And then if a trigger expression is re-evaluated as false, and if a special recovery expression is also set and is evaluated as true, then a problem event is recovered. So the problem event is resolved. And in the corresponding section of monitoring problems, you can see the resulting set of data for the problem event, either in a problem state or a resolve state, the time when the problem occurred or resolved, the severity of the problem, recovery time, or it would be blank for a just emerged problem which is still in a problem state, the host where the trigger has fired, and the trigger which generated the problem event name, and the duration for the problem. Zabbix provides flexible options to customize what is being displayed in a set of fields shown for problem event. By default, if just a name of the trigger is specified and there is no event name defined, the problem event name will be the same as the trigger name. But you can now override the latest versions of Zabbix allow this. You can now override the event name by specifying and defining lots of meaningful information. Like in this example, we display all, the value that has been read at the time when a trigger expression has been evaluated as true, at that precise moment. Then we also display last hour average for the value, and an additional field, operational data, is also populated, and it shows the last value, the most recent value that has been obtained by Zabbix. And this provides us lots of useful information to instantly see how the problem developed and what is its current state. So, okay, the CPU load was rather high, and within the hour, and its average value has been also high, but current value is diminishing, so we could conclude that the situation now is improving. Just to remind you that operational data field is not shown by default. Yeah, so this flip switch is by default set to none. In case you would like the operational data field to be seen, you need to switch it to either separately or with a problem name. So here is how by default it looks like. So nothing is displayed. Then if separately there is an additional column operational data with a value, and also it is possible to display current operational data in line with the problem name. It will be enclosed into the braces. Expression macros. Yeah. So one of the interesting features, one of the interesting information pieces that we displayed was average value for the last hour, and it was obtained by using an expression macro. So how the overall syntax of an expression macro looks like. So we have an opening curly brace, then a question mark, then followed by expression itself and the closing curly brace. So expression macro, this expression part, can contain any supported function like minimum, maximum, average, last, and many others available in Zabbix, and can reference any existing key. So let us view how we received an average for the CPU load within the last hour. So we're defining that we are referencing expression macro by opening curly brace, then a question mark. We use function average, the time period for which we are evaluating the item data is 1 hour. H suffix stands for hours, and then we are referencing what item should be evaluated. So first it is a host name, and after the slash there is a item key. Yeah, in case you're referencing the host, the current host, for example, in regard to problem event, this is the host where a trigger fired and to which the host to which this trigger belongs to, we can omit specifying the host, and it will be just a blank. Yeah, so it would look like double slash and then the item key, and this is how we receive this average value for the last hour. If the function that we are applying by an expression macro gives us outputs value which is too precise, we can additionally format it with a macro function, and in this example we are using FMT number, and in the parentheses we define how many digits after the decimal point we would like to display. This is the raw output without any formatting function applied, and this is when FMT num with parameter 2 is applied, so we see only 2 digits after the floating point. Yeah, this can be useful, yeah, to make your data that you are showing in the problem or operational data field more compact and appealing. Where else expression macros can be used? In network maps for element labels, shape labels, and link labels. Here, for example, for an element label, we are using a combination of built-in macros, static text, and also expression macros. This is an opening curly brace, question mark, and we are using function last, average, and minimum. Then we are referencing the same host to which this label is applied, and then followed by the item key that we would like this function to be applied to. Like last, we do not specify any time interval. For average and minimum, we need to specify time interval, which is 5 minutes in this example. Graph names, trigger event names, and operational data can use expression macros. Also trigger-based notifications, like for problem emerging, updating the problem, and recovery of the problem, we can use expression macros. By altering message templates, we can specify expression macros and can add some maybe useful information to the message body or message subject. Let us proceed to the next topic, which is tags and problem generation modes. Tags nowadays are everywhere in Zabbix, and let us start with defining what is a tag. A tag is a keyword or term assigned to a piece of information, and in Zabbix, tags are implemented as a key and value pair. Also, I need to point out that tag in Zabbix can also exist just with a name, without any value. This is also a possibility. And tags are generally chosen informally or by the person who creates some entity or views the resulting data. But of course, this tag naming policy can be regulated by your company or some controlled vocabulary. The best practice, the main advice here is to assign meaningful names that really add and expand information on your entities, like for example defining the responsible team or person, environment type like QA, maybe test or production, location, maybe geographical or location, or the server rack or the server room, application like general or Zabbix role items, which are being then pre-processed, and multiple dependent items are derived from such Zabbix role items, components to which items belong to, like memory, disk, CPU, network, and so on. Availability, low, critical. So it is advisable to add tags and to choose them so that they would add additional meaningful information to your entities. And where you can define tags in Zabbix? There are multiple places for that. So tags can be defined for host and templates as such, so on the host and template level, and to the entities like items and triggers on host and template level. Web scenarios can have tags of their own. Different kind of prototypes defined in low-level discovery rules, like host prototypes, item prototypes, trigger prototypes, graph prototypes. Can have tags defined for on their own level. Services, so SLA, now is fully based on tags on matching problem and service tags, and the resulting problem event that is being generated will have the full tags inherited from all the parent entities, all the way from template to host to trigger to item, and we can end up with quite a long set of tags in the resulting problem event. So tag usage, tag names and values, where can you use them? You can, first of all, you can use them as an additional option for filtering in monitoring, in configuration sections and all of their subsections. So like in this example, latest data tags, and you can define if you would like to see only information that has some tags or a pair of tag name and tag value, and you can define here multiple such pairs, narrowing down your search even further. You can limit the problem events that are seen by a particular user group. There is special setting, tag filter, that can be used for that. Trigger action conditions, so text can be used as additional conditions where you would like to execute some trigger actions like notification or remediation script. Applying maintenance, you can granularly suppress problem events which have some specific tags or pairs of tag name and value as a filtering option in for each function. For each functions allow you to get information from multiple hosts which have similar, almost identical items with the same item key, and you can filter in or filter out unneeded or just needed host by specifying the tags as an additional filtering option. Problem event correlation. So global and trigger-based event correlation fully relies on tags, and we will at the end of the presentation I will demonstrate you how trigger-based event correlation works and how triggers there are matched. Event generation mode. In the trigger parameters, it is also possible to configure two problem event generation modes, single and multiple. And what does it mean? When, as by default, this flip switch is set to single, only one problem event is generated in response to a trigger transition into a problem state. So while it is in problem state, regardless of what values are incoming, it will stay in the problem state and no additional problem events will be generated. If this switch is set to multiple, then each time the trigger expression is evaluated or re-evaluated as true upon the new data, incoming data, a new problem event is generated. And when can it be useful? When, for example, you're monitoring an SNMP trap, so some information that is being sent by your device or system via SNMP, and this information can reference different entities like different power supply units or different networking interfaces, and you would like to react to each such event, or maybe there is an information of unauthorized access, so you would like to create a problem event on each such unauthorized access attempt. And here is an illustration how it looks like, just one problem, and here are subsequent problem events when generation mode is set to multiple with the same problem name, almost the same, just a bit different values of the items that triggered the problem event. Trigger-based event correlation. So it allows you to correlate separate problems reported by one and the same trigger. So like I've already mentioned, when you're monitoring SNMP traps with just a single item, and you set up a trigger which reacts to incoming values received by this item. And this data received can be referencing different entities, and you would like to create a problem event which would be somehow marked with this entity to which this event relates to, and then when you receive a recovery information, then you would like to only close the event to which this recovery information refers to. And in order to do this, you need to specify the problem expression, and that's like standard. Then you need to set OK generation, event generation to recovery expression. Define the recovery expression, and this is our condition when we would like to resolve a problem event. In this example, we are finding the string which contains bad for problem to generate a problem event, and we are searching the string for keyword good to generate a recovery expression. But if we just do this, it would a recovery expression would close all the problems generated. So we need somehow to distinguish to what entity this recovery and problem event related to. So in order to do this, we set problem event generation to multiple, so we would react to each such event, and then OK event closes all problems if tag values match. And here is where tags really gain their significance. So we said that we would like the name of the tag to be matched as host ID, and we will match it by the value provided for this tag host ID. And we then transition to the tags tab and define. So trigger tags, host ID is the name by which we are distinguishing problem and recovery events. And what we are doing by using the item value which triggered the problem event, we apply a macro function which is called reg sub. So we are reading out some substring from defined by a regular expression. So we are looking for a string health test result for instance ID, and then we specify a regular expression. So we would like to read out all the digits which follow this static text line, and we are referencing the match pattern, which is the first one. This is the only one we defined here, and this substring will be assigned as a value to the tag named host ID. So let me demonstrate you how it looks in real life. So we are taking a host correlation host, no data is found here, and we are generating a problem event. So for ID 10,050 we are generating a problem event with defining a keyword bad, and we assign a tag host ID 10,050 which is read out by substring macro function. And then we would like to generate one more problem event with a different ID. You see that now a different ID is assigned in the tags. And now let us recover the first one and see if it doesn't recover the second problem event. So ID and the keyword for recovery. Let's see if it matches the tag. Let us send it and refresh. So you see only one problem event is recovered, problem is resolved, matching the tag which is contained in the recovery message. Let us then recover the second one. So let us reference the ID, which should be 10,051, and the keyword is good for recovery message. So let us see if it recovers the problem event. It is sent, and let us refresh, and we see that now both events are resolved. So that would be all for such big and profound topics, just an outline of Zabbix capabilities on tags, problem event generation, customization of those problem events, and trigger-based correlation. Thank you, colleagues. Thank you for your attention.